Okay, and welcome to the last day of probability. This is chapter 13.4 in your books if you want to follow along. And this is the probability of compound events. What is compound events? Well, let's start off with some vocabulary to help explain it. A compound event combines two or more events using the words and or the word or. Okay, so we'll kind of get into the basics of that. There's like a one draw or one roll compound events, and then there's multiple roll or multiple draw compound events. There are independent events. The occurrence of one event has no effect on the occurrence of the other. So this would be an example of like a multi-draw or a multi-roll type of problem. But again, it sounds maybe a little bit more wordy than it really is. But when you see it and we go through it, you'll have a better idea as to how it works. And then there are dependent events, where the occurrence of one event affects the occurrence of the other event. Again, you'll see this once we go through it, but just keep in mind these are the big two ones that are probably, if you were to say there were any difficult ones in this unit, these two would be the ones that would be independent events and dependent events. Let's start with a simple one though. You have a standard deck of playing cards. Standard deck has 13 cards, ace, 2 through 10, jack, queen, and king, in each of the four suits, diamonds, spades, hearts, and clubs, for a total of 52 cards. Okay? What is the probability of drawing a 6 or a jack? Now, this one is a little bit easy because we're only talking about one draw. So this is one draw because it doesn't mention anything else. It just says you're drawing, what's the probability of drawing a 6 or a jack? So we need to find the probability of each. Well, probability of drawing a 6, there are 4 6s in a deck of cards. So 4 6s out of 52 cards, or 4 cards out of 52 cards are 6s. And then for jacks, 4 cards out of 52 are jacks. Okay, since we're only doing one draw, all you have to do is add their probabilities together. So 4 plus 4 is 8, and since we're adding fractions, you want to keep the denominator. So in other words, make sure they're the same too. Okay, if they're not the same, then you need to find the greatest common denominator and fix it so that you can add them together. But these are good. They both have 52. So you can reduce 8 over 52 to 2 over 13, because 4 goes into 8 twice and 4 goes into 52 13 times. So this is technically your correct answer. Now, if you wanted to work with numbers that were a little bit easier, you'll notice that 4 over 52 actually reduces. So when you can, do this, especially with card problems. Okay, so 4 over 52 reduces to 1 over 13. So you can just do 1 over 13 plus 1 over 13 equals 2 over 13, which obviously is the same answer there. So if you want to reduce on the front end, that's fine. If you want to do it on the back end, that's fine too. You're going to come up with the same answer either way. Okay, let's try another one. What is the probability of drawing a heart or a spade? Well, again, we're going to give you all this information just in case you don't know the ins and outs of decks of cards, but there are 4 suits. So in each suit, there are 13 cards. So we're going to say 13 over 52 is hearts. Spades has the same amount of cards, so 13 over 52. And that comes out to 26 over 52, which reduces to 1/2. So that would be your answer. And again, if you wanted, you could reduce it. 13 over 52 reduces to 1/4. So 1/4 plus 1/4 equals 2/4, which equals 1/2. So either way, you get the same answer. Remember, when you're adding fractions, you keep the denominator. You do not add it. You only add the numerator. So you only add the top part, leave the bottom part alone. And they have to be the same, bottom parts, that is. Okay, let's move on to the little more complex ones. Independent events. So given the fact that you have the same deck of cards, so 4 suits, 13 cards in each suit, what's the probability of drawing a heart, putting the card back, and then drawing another heart? So we've got 2 drawings here, which means we should have 2 probabilities that we're multiplying together because we have multiple drawings. So kind of think of it like that. Do I have one drawing or do I have multiple drawings? If I have multiple drawings, I multiply. So probability of drawing a heart is 13 over 52. Now we put that card back. So the second time, we have the same probability of drawing a heart. Okay? Now we know that 13 over 52 reduces, so let's go ahead and do that so that we don't have to deal with multiplying 13 times 13 and 52 times 52. So we're going to say that's 1/4 times 1/4. So there is a 1 in 16 chance of drawing a heart, putting it back, and then drawing another heart. Okay? So hopefully you see the difference there. We have 1, 2 draws, which means multiple drawings, which means we multiply. So we just take the probability in both cases, multiply them together, and that gives us our answer. So remember, one drawing, you add. More than one drawing, you multiply. Okay, now we have dependent events. Okay, this one's a little bit different. It's similar, but there's a slight difference. So again, given the same deck of cards, what is the probability that you draw a king, you keep the card, and then you draw another king? So this is going to be the clue right here that this is a dependent event. Okay, you keep the card. You don't replace the card. Those are words you're going to look for dependent events. For independent events, you put the card back. You replace the card. So that's going to tell you that that's an independent event. Now, how many draws do we have? There are 1, 2 draws, which means there are multiple draws, which means we multiply. Okay, so what's the probability we draw a king? There are 4 kings in a deck of cards out of 52 cards. Okay, now we kept the card. So how many cards do we have now first? Well, we don't have 52 anymore because we've got one of them. So that means we have 51 cards in our deck now and only 3 kings left. So you would multiply this out, which would give you 4 times 3 is 12. Now remember, when you're multiplying fractions, you multiply the numerators and the denominators. And 52 times 51 is 2,652, which does reduce. But I'm going to show you that you can reduce this first. So 4 times 52, or not 4 times 52, 4 over 52, we said reduces to 1 over 13, right? And 3 over 51 actually reduces to 1 over 17. Okay? So that right there is going to give you, let's see, 17 times 13, 21, 51, 0. So 221. So it'd be a 1 in 221 chance of drawing a king, keeping it, and then drawing another king. All right, moving on to the next part. This part is on your own. So you roll a number cube, find the probability that you roll a 1 or a 6. You roll 2 number cubes, find the probability that you roll a 1 first and a 2 second. And the last one, a bag contains 6 red marbles, 5 green marbles, and 3 blue marbles. You randomly draw 2, one at a time. Find the probability that both are red if you do not replace the first marble. So go ahead and take a few minutes. I want you to pause the video here, do those 3 on your own. These could very well be the questions that I have for the pop quiz, so make sure you show your work, you figure out what you did. Okay, so go ahead and pause, and we'll come back. Okay, so first one, what kind of probability is this? Well, you roll a number cube. Okay, it sounds like 1 to me because there's only 1 roll there. So the probability that you roll a 1 or a 6, well, the probability of rolling a 1 is 1 in 6, right? The probability of rolling a 6 is 1 in 6. So we just add those together because this is 1 roll. So 1 plus 1, because our denominators are the same, is 2 over 6, which reduces to 1/3. So we have 1 in 3 probability of rolling a 1 or a 6. Okay, now you roll 2 number cubes. So we're rolling 1 number cube and then we're rolling a second number cube. So that's multiple rolls. So what's the probability that you roll a 1 first and a 2 second? Well, the probability of rolling a 1 is still 1 in 6. The probability of rolling a 2 is also 1 in 6. But this time we're multiplying because we have 2 number cubes. Okay? So 1 times 1 is 1. 6 times 6 is 36. So that would be your probability. Okay. And last one. A bag contains 6 red marbles, 5 green marbles, and 3 blue marbles. You randomly draw 2, one at a time. Find the probability that both are red if you do not replace the first marble. So this one is an independent. I'm sorry, dependent. This one was independent. And this was just regular old compound probability problem, you know, the real basic one. But, so, we've got 6 red marbles, 5 green, and 3 blue, which gives us a total of 6 plus 5 is 11, plus 3 is 14. Okay? And we want to find the probability that both are red. So the first draw, we have a likelihood or a probability of 6 over 14. The second one, we have 1 less marble, so it's going to be over 13, and we have 1 less red marble, so that one's going to be over 5. When you multiply this out, you get 30 over 182. Both even numbers, so they both at least divide by 2, so let's start with that. That gives you 15 over 91, and that does not reduce any further. So the probability of drawing a red, if you draw one at a time and you draw twice, is 15 over 91. I know this can be a little confusing, so we'll be going through this a little bit more in class with different scenarios. And if you have any questions, make notes on your paper now, bring them with you to class tomorrow, and ask them. And I'd just like to finish off with this little note to you guys. Have a good one. We'll see you in class.